Good morning, everyone. Welcome to another episode of Sound Talk Show. We are going to code Wolfram Language today, Wolfram Language. And if you are watching this offline, play at 1.5 speed. If you are here, say hi. So Wolfram Language coding, this is for beginners. So if you already know Wolfram Language, then you will not get much out of it. But this is for beginners. So I'm gonna work on my Wolfram Language tutorial from the ground up for programmers. So you can just search for it, you'll find it. So this is, let me see if I can see my screen. Yes, everything is good. So Wolfram Language for programmers, okay? So this is on xali.info, no S in HTTPS, no S, okay? So then you can visit it, and you can also download it here. It's free since a few years ago, complete tutorial. And I'm going to work on update some part of the, make my tutorial better. So list operations. So here's an introduction to list data structure in Wolfram Language, and then list operations. So there's tons of it. Like in a typical programming language, in Perl, in JavaScript, in Python, in Ruby, maybe you have, let's say, 20 operations on list or methods, functions. But in Wolfram Language, you would have you have 100. Okay, so Wolfram Language is a magnitude higher level. I might show some of it. So, but anyway, I'm going to work on it. So this is Wolfram Language for beginners, and also I'm using Emacs, the most advanced text editor, and I'm gonna work. So for those of you Emacs users, this is also a Emacs work session. Okay, so let's start Wolfram Language. Okay, start. I'm also using Wolfram Language in Emacs. So there is XA Wolfram mode that allows me to work in Wolfram Language in Emacs, running the code and editing and everything. So, but right now you are looking at the Wolfram Language notebook. Okay. Now for interest, why don't I show something fancy here just to begin with, for people to come in. Okay, so Wolfram Language, download Wolfram. Let's go to Wolfram Language. So I did like hundreds of videos before, so you can watch Wolfram Language tutorial by video. There's hundreds of them in the past 4 years. Okay, so let me just go to, let's run something interesting and fancy. Okay, so this is always a fantastic example to show. So, okay, so paste it. And, okay, the font is too large. Let's just make it 25, okay? So, Shift Enter to run it. So there you have it. This is inversion, geometric inversion of 3D cubes in a rectangular array. So what you get is this fantastic and beautiful. Okay, so this is just a demo, but that's we did this live a few years ago. So if you search for geometric inversion, in fact, I did several videos about this. We coded this live. Okay, including full struggle session and all. But so if you want to do this in C, that's gonna be 1,000 lines of code, probably. C with OpenGL or whatever. If you do this in Python with whatever libraries they have, it's gonna be a few hundred lines of code. Okay. So anyway, so here is what we're gonna do. Okay, so let me show this. This is what I need to work on. So when I walk back and forth, take my notes, I take notes. So these are the screenshots of the notes I've taken that I need to improve my tutorial, create more examples. Okay, so we're gonna based on this. So first of all, let's do the join. Okay, so let's start to go to the Wolfram language for programmers. Then let's go to the list section, list, and list operations. So you go down, list operations, copy the URL and paste it here, make a link, go to it, list operations. Okay, in fact, we want, the one we want is join and union, this one. On this page, there's no examples, so let's show examples. So search for join, open it, copy the file path, close, and link, paste the link, linkify, make a list, go to the page, okay, and update today's date, so you can see there it is. Okay, then join. Okay, so join needs an example. Wolfram, pop it out. Okay, join, and let's just say 1 2 3 1 2 3. Anyone here? Say hi. Okay, 7 people watching, and let's say ABC. Okay, so let's clear. So run it. That will just join two lists. Okay, so this is output and this is comma. Okay, so now syntax correct, showing browser, fantastic. We got the example. Now also union, intersection, complement. Okay, so union. Let's see. Union. Okay, union. 1 2 3. Now union is interesting because let's just say, because it will remove duplicate. Let's say 1 2 4. Okay, then run it. So you are looking at XOR Wolfram mode. If you search for it, you can see, for example, let me show. Okay, so XOR Wolfram mode. Okay, XOR Wolfram mode, and this is about 3,000 lines, and you can get it on GitHub. So show the website. This is XOR Wolfram mode for Emacs, and you can get it on GitHub. Okay, free. Thanks to Wolfram Research for supporting me. Okay, so that's XOR Wolfram mode. Copy, close. Now let's so here is union. You see 1 2 3 and 1 2 4. It becomes 1 2 3 4. So let's just it's just a simple example. When you are writing a tutorial, the simple example is the best. You want the example to be the simplest that showcase what this function do. Okay, so in this example, you can see, you know, the same elements are not included in the result. Okay, so let's close that. Actually, so I want to paste the XOR Wolfram mode showing browser. There it is. XOR Wolfram mode for Emacs. Okay, so back here. So now back to this page, we have example for join, union, intersection. Actually, we need to go faster because there's quite a few things to do. Okay, so pop it out. So intersection. Yeah, let's use the same example. Run it. On the pink window, you can see all my command calls and their keystroke on the left. So you see, I just called XOR Wolfram eval region, and here is the result, the intersection of two lists. Okay, put it back, syntax correct, to go to the browser, show refresh. There it is, complement. Okay, complement. Now in Python or JavaScript, I believe, typically they name this function as difference of two sets. But mathematically, you don't say difference. Usually you say complement. But difference is actually the easier to understand, you know, because one set minus another. but mathematically they are traditionally called complement. Okay, complement, completion. Okay, complement. So let's run this example. Can it demonstrate complement? Yes, because 3 is not in the second list. Okay, syntax correct, fantastic. So, and update the date. The date is updated. So you got join, union, intersection, complement. It's okay. We added examples. That's good enough. Okay, so delete. So this join, now this, you see, join operation is quite different from the others, union, intersection, and complement. Because the union, intersection, complement, they are set operations, like in set theory. Join is simply concatenate, two lists. So the join needs to be separate from them. They need to have a new section, okay? So join. So let's see how we're gonna do this. Cut, yeah. So new one, new section, and new definition list, and paste that there, and and remove this to do and date. Join lists, okay? Capitalize, make it H2, showing browser. Fantastic. Join lists. Then list the set, union, intersection, complement. Fantastic. Okay, now that's good. Join, union, intersect. Yeah, that's good. Okay, now this screenshot done. Delete. Next. Okay, this is about auto hotkey. So we did a video 2 days ago about auto hotkey. So that, so let's not do this. This is also auto hotkey. Auto hotkey. Okay, so watch the video from 2 days ago. 2 days ago. Hello, post 1999. Hello, ACP Junior. Curious, does join decouple the elements, dedupe the elements? No, they just concatenate. If you want to dedupe the elements, that's called union. Okay, I hope I answered that. That's what you meant. Okay, so next, so this join, union, intersection needs to move up, because join is a very common operation in all programming languages. Okay, so search for join. So you go down into this this I call this box. Okay, so go down so you can see this box. This is what I call topic box. Okay, topic box. So the join operation needs to go up. So search for join, cut. Okay, and where do you want it? You want to let's see. In the browser, it's easier to see. You want to be before filter. Okay, so search for filter. Yeah, put it there. Now watch the pink window. It'll show the command I call to update all topic boxes in all pages in the entire website of 10,000 files. So press. So you see each page. So let me show you the output. So each page, there's 10,000 pages. So each page, they show you which page has been updated, which page does not have the topic box before, but now it's added. So this is output. That's an Emacs command I wrote, which is the name of that command is you see XHTML update topic boxes. Can you guys see, is everything going well? Yeah. Okay. So now let's go back. So you can see, in fact, you can see here, you can see the join somewhere so it's at the bottom, you see. Now you click list operations. Now the join is right here before filter. You click create table and go down to the topic box, and you can see the join operation is right before filter. So it updates any page, it updates essentially all topic boxes scattered in all pages. Okay, this one is done. So let's see next. Delete. Now remember to play at 1.5 speed if you are watching this offline. And any more comments? Praveen, yes. Yes, what? Generating nested list with table. So let me demonstrate this. Okay, so you got this operation, these operations, and one of the most useful is table. And I want to change some wording. Okay, so copy the URL back to Emacs, close that, and paste the link, linkify, make a list, combine the list, okay, then open the page showing browser. So that is a table. Now search for nest. So this example is about creating nested table, which I can show you. Okay, so for example, copy that. Let's do in Wolfram Language. Paste it, Shift Enter to run it. There it is. Now do it again. Now this time show in tree form. You see, it makes it easier to see. So what this table does in this particular example is it generates a three-dimensional array, kind of. I mean, there are many names to call it. You can call it a 3D matrix or 3D array or three-dimensional rectangular array, or you can also call it nested list. Okay, many name to go by. So, but what I want to say here is change the title. So this is regarding writing. So I'm saying generating nested list. So now I want to change it to rectangular. Rectangle. Don't I have a shortcut? Rectangle. Oh, I don't have a shortcut. Let's see. Let's not worry about it. Okay. Let's just spell it out. So why do I want to rename it rectangular array? Because that's more specific. Because when you say nested list, the list may be what's so-called jagged array. That is, it's not a square rectangle. It's not a square array. It may have, some of the leaves may just have one leaf. Some nodes have two leaves. Some nodes may have 5 leaves. So in that case, that's a nested list, still true, but that's no longer rectangular array. However, the table function only generates always rectangular array. Okay, so it doesn't generate arbitrary tree. So therefore, the naming of this title should be better if you say rectangular array. Okay, also don't say generating, don't use the verb. Okay, generate, just simple now. Okay, as opposed to the so-called it's called active voice, active voice, idiotic. That's a very famous writing advice. You must use active voice, which is not true. In fact, if you are writing mathematics, always use passive voice. Like you don't want to put yourself in the center, nor do you want to tell readers about some action. Oh, you gotta do this or do that. No. If you want to write any computer documentation, especially if you want to write it like a mathematics code and precise, you want to write it in a descriptive way. Okay, just describe exactly what happens. No action at all. Don't say, oh, after you do this, then this will happen, and this is the result. Don't do that. Like you like specification. Mathematics, it's about description. Okay, that's the way math works. So generate rectangular array with table. So that's what you say. Don't say generating. Generating. So my writing style back to 20 years ago, I always use generating, and it's no good. Okay, so at this rate, we'll never go far. So there's a lot to do. Okay, so that's done. Okay, now there's also minor details. For example, in this example, I can show you quickly. Okay, so copy this example. What it does is paste it. It just generates a flat list from 1 to 3 instead of 1/2. So Wolfram language is symbolic. So you can, when you have a fraction, it generates the result in fraction. You see, fantastic. Now there's a wording problem because you see here is another technical writing documentation detail about formatting. There's so many issues about technical writing documentation. There's organization, there's a writing style, there is a in the style of exposition, there's the kind of words you use, and there's organization issues, and one of them is syntactical formatting issue. Like programming languages, you have, function, methods, objects, variables, and arguments. In this case, these are arguments. Some of them are optional. So how do you indicate to people which part are variables, which part are function name, which part are object, or which part are, arguments, So arguments in a sense is also a variable, or they are also called parameter. So there's many formatting issues. Now in this case, what I want to change is this. You see, I'm saying I mean Emacs. In fact, I want to remove the I. Okay, don't say I mean Emacs. Okay, so yeah, so let's just do that. As to why, well, if I explain why, it's gonna take a lot more time because first of all, you need to understand what this does. Then so it takes a variable. I is a variable. Then here I means it's a minimum. It's a value that to begin with for I. Okay, so this I mean refers to a minimum value, starting value for the variable I. So that's why I name it I mean. And similarly, Imax is the maximum value, and Di is the D is delta, like differential, the step. Okay, each step you take. So I wrote it probably influenced from the Wolfram language documentation. Like when you write a doc, you can also look at other people's, documentation. Python, so many languages, Python, Ruby, so you can see what's their documentation style. Java, most of them are like the worst shit, like the Mozilla JavaScript documentation, the Python documentation, they are the worst of the worst. Like they don't know how to write. It is like complete bullshit. Like, and the Unix man pages, like it very popular. It's like it's an epidemic in computing industry. The Unix man pages, the Apache documentation, like they don't know how to write. They just blurb, blurb, blurb. Oh, you blurb, and they think it's funny, especially in the with the Unix documentation. Perl, Python is all crap, like the worst crap. Okay, Java, the language documentation is the superb, professionally written Java. Okay, and Wolfram language also superb. They are in these two are examples of the best technical writing. Okay, however, they are in completely different style. Okay, anyway, I talk about this because it's one of my obsession, writing documentation and tutorials, and writing in general. Okay, like creative writing. So I've been obsessing about it for like 30 years, like most of my life. So I know all these details. Anyway, so this is Wolfram language documentation. So anyway, let me just change this to make a backup, show in browser. So let's update the last updated date. Then let's make a change. I mean to just mean. Okay, it's just not I mean. Okay, In fact, wait, hold on a second. So actually I want to change one shot, the and the Emacs, change them both, okay? So change with just M, do it, 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 okay? Now go back to browser. Now when I refresh, all these Emacs will be changed. Do it. Fantastic. Now this DI also needs to change. So search for DI. Yeah, so this DI will be just say step, okay? Okay, this is about technical writing, and especially it's about formatting, syntax, code formatting issues, convention, and so okay. So this part is done. Make sure delete it. Okay, make sure I got it. Yeah. Okay, and what about this? Okay, so this part is about generating nested table. So let me show you guys just in general what is the table does. Okay, what is your opinion on text info? Okay, text info, that's esoteric topic that's related to GNU Emacs or the GNU Software Foundation, their software documentation. They use a format called text info. I won't go into it, but let me talk about it for 1 minute, okay? In fact, you just search for Xali text info. You'll find the article. So Emacs should adopt HTML as text info replacement. For example, that's one article. Open it. Okay, wait, go back. Opening a new page. Wait, so the AI started to talk. Xali is a prominent figure known for his extensive online resources on Emacs and programming, including discussion on text info documentation system. He has expressed criticism regarding text info, advocating for the adoption of HTML as replacement for text info in Emacs documentation. That's correct. Superb technology, unprecedented in human history. This AI today, and also very dangerous, is happening. Anyway, Lee argues that current text info. Anyway, that's interesting. Okay, let's screenshot this. Okay, so but let's just go to my page. Okay, blah 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 blah. Okay, so Ultimate Hacking Keyboard, that's the one I'm using. Fantastic. I did a review a week ago, full in-depth review. Watch that. Okay, so now click that, press that button. That's middle click. Press that button. That's middle click. Oh, this guy is a scum. He copied my website and put on his website. It's fucking scum. This guy Wesley. So his page is not coming up. Okay, so he's like, so sometimes people, I think he bought my tutorial like 10 years ago or more, and he put on his website and forgot about it. Anyway, so Hacker News added he seems to have a lot of interesting and stuff, and God, I'm about as good as dead. That's 2014. Okay, my hardship in my life. Xali can program a line of Lisp on his own. This guy, whose name is he's a German guy, Lisp M. Online he goes by the handle Lisp M, kind of stand for Lisp machine. Okay, his name is I shouldn't talk. I talked about this before, but anyway, he's a Xali hater. Every time my post got posted somewhere, not by me, I never posted to Hacker News. Okay, maybe one time. Okay, one time they were talking about me. Like in the past, in all my life, I posted to Hacker News one time to reply to some some bad shit about me. So I never posted my website to Hacker News. Okay, the other people, thank you guys, they posted. So, but there's this Lisp M guy, which I kind of know. We kind of talked like almost 20 years ago. He doesn't like my stuff. He doesn't like my opinion. So every time he sees some posts about me, he's gonna badmouth it. Okay, I talked about this. Yeah, let me mention it because this is really a scum. Okay, this is verging on defamation. Okay, verging on defamation, and what's the other word? You know, that's legal defamation. Okay, you can sue the guy. You know, you can say, let me tell you, young people, if you don't know about this issue, if you don't like someone, you can say it. You know, I don't like this guy. I think his opinion is bullshit. I think he's stupid. I think he's an idiot. He's a fuckface. He's a scumbag. You can say all that, no problem. But when you say something that is actual, that's concrete but not factual, and damaging, then you gotta be careful. Okay, you cannot say, "Oh, this guy, he never coded a single line of Lisp." That's verging on defamation because that's a lie. Or if you have, or whether, or you have to prove it. Okay, because that's damaging the reputation of another person. Okay, so you can say he's a fuckface. You can say he's stupid, no problem. You know, you can say Xadi is a stupid, or you can say I don't agree with his opinion. He's a nut job. That's all fine. But if you say like he cheated on something, or he didn't do this, or he did that, something nasty, you know, then you need to prove it. Okay, otherwise that's defamation. What's the other word? You know, so that's legal, a legal problem. That's illegal. Okay, so but there's this guy Lisp M. So let me just search it so you guys know, because he been doing that for like 10 years. You know, like every few years. Okay, this guy, who is Lisp M? Rainier Joshwick, a scumbag from Germany. He's an old Lisper, perhaps 10 years older than me. So maybe he's 60 something. Okay, he's an old like Lisp machine guy from the 1970s, 80s. So he hates me. So every time he sees some post, so here's a collection. You know, he just start to bullshit, you know, badmouth about me. Okay, so I, you know, after he done this many times, I created a page by itself, 2023, so people can actually see my documentation on this scumbag. Okay, Lisp M. Rainer Joshwick, something. Okay, a German guy. Okay, so let's copy that. So let's show that. Sorry for the digression. We're gonna go back to what we're doing. Close that. So, but okay. Okay, so let's go back. So you were saying, what's your opinion on text info? Okay, so you can, you know, I don't like it. Basically, I think it's not I don't like it, but it's Asian. Okay, it needs to change. And by the way, are you the guy on Discord who was making trouble? Prash or whatever the name, I forgot. Slander, yeah, that's the word. Slander, defamation or slander. I don't know exactly what's the difference, but they kind of similar. Okay, that's that's illegal. Okay. So ACP Junior, thank you. So Ebrin must say, ignore the noise. You are a resource, and personally, I have learned loads from your video. Thank you. Thank you, guys. Okay, so let's get back to the coding Wolfram language. Actually, we've been going on for 30 minutes. There's a lot to do actually. So yeah, so let's see, where are we? Okay, close that. We're working on list. So let's get back to work on this. Okay. Yeah, so I'm not on Discord. Oh, okay. Oh, NASA, right. NASA guy. Okay, whatever. Did you work for NASA? Why is that NASA logo? Yeah, I confused you with someone else. So anyway, so let's get back to, yeah, let me just show you guys what table does. Okay, so table is the most used function in Wolfram language to generate a list or rectangular array. So let me just demo. Okay, so because it's easier if I just demo it. Of course, you can read my tutorial. Everything is here. But so let's switch to Wolfram language mode. Table. Okay, so the simplest case is just like that. You want to repeat that item 3 times. Okay. Then, so let me show you another example. So let's say for that, different expression, repeat 3 times. Okay. Now level up. Now you want to repeat, let's say x I from 1 2 3. Okay, run it. You get 1 2 3. Oh wait. Oh yeah. So this needs to be x. Okay. X 1 2 3. Okay. So that 3 is the maximal value. Now, if you put 2 numbers here, let's say 4, 7, then you get 4, 5, 6, 7. Okay. So all these are table, this variation. By the way, if you are a Python coder, table is just like Python's list comprehension, idiotic jargon from the Python idiots. And from their idiotic syntax, list comprehension, they think they are mathematicians. But they created the worst syntax and also the worst name for the syntax. The semantics list comprehension is the worst shit possible. And the name for it, list comprehension, is the most idiotic. Okay, the Python idiots. Guido van Rossum, one of the lowest IQ among programming language creators. Okay, but he think he's a hotshot, Python. Like he's got a mentality, like he think he's the great designer, and but his result is not as so great, but he constantly has this like passive aggressive attitude to say, yeah, but I'm the greatest. Language, creating a language is not just about solving puzzles, the way he writes, like Guido van Rossum, the most idiotic guy. Okay, so table is similar to Python's list comprehension. Okay, by the way, Haskell also uses that term, which is idiotic, Haskell. In Wolfram language, if you want to generate any list or any rectangular array, you use the table function. Okay, these are the variations I'm showing you. Okay, now, so these are consecutive values. Okay, so but you can also have, let's say, x 4. So in this example, that x, let me show you some simple example. Let's say x pi. Okay, run it. You see, 4 pi, 5 pi, 6 pi, 7 pi. It can be any expression. Okay, so let's say x power, second power. Wait, where is the power key there? Let's say x raised to second power. Run it. You see, 16, 15, 16, 25, 36, 49. Okay, now let's say x second power plus pi plus plus, where's the plus key? New keyboard, so that's wrong. That's where is my plus key? Plus key is always problematic. Okay, let's say plus 3. Okay, it can also be pi or whatever. You see, oh, there's a number. Okay, let's not use a number, because when you use a number, it just compute the whole thing, so it's hard to understand. So let's use a symbol. Let's say y, x squared plus y, x from 4 to 7. There it is. Okay, now you see the first part can be any expression, not just, simple. It can be complicated equation or whatever. So for example, now let's add another element. Let's say x times y, x times y, or and plus z or whatever. Okay, run it. You see, it gets big. Let's say, let's format it. Okay, there we have it. Now all these are flat lists. Okay, now let's get into two-dimensional. Okay, so two-dimensional case example. Okay, so same thing, start simple. Let's start with just a single x. So x, let's say, now let's give a list x and y. Now x from 1 to 3 and y from 1 to 3. Okay, let's say 2. Okay, because when you have multiple nesting, it becomes the huge very fast. Okay, run it. So you see, x goes from 1 to 3. So x is 1, x equals to 2, x equals to 3. Then y goes from 1 to 2. So for each time x changes, the y, you see, x, now in this part, x is 1, y is 1, 2. Okay. Now in the second part, so let's format it. Okay, so let's format it so it's easier to see. What? Okay, so the second part, x is 2, y is 1 and 2. The third part, x is 3, y is 1 and 3. So this is a 2D matrix, a rectangular matrix. Actually, it's a bit complicated. Let's make this into this form so the braces does not confuse you. Okay, that's right. Okay, so now it's much more clear. See, it's a bit more complicated here because you are using a list which is represented by the braces, the curly brackets. So that kind of gets you confused. So let's remove that. Okay, so in this example, you can clearly see a two-dimensional matrix. Okay, because you have two iterations, x and y. Okay, now similarly, you can have any arbitrary complicated expression. Okay, let's say x plus y, let's say pi, let's say, and I, the complex number. Okay, then you got that, and this can be three-dimensional. Okay, so let's say if you have the z component, let's say -5 to -3 z, so you want the z component, let's say times z. Okay, here. So now you get a three-dimensional matrix, and each element is this expression. Okay, and it can also, again, it can contain fraction. Okay, let's actually try fraction example because that's fun. Okay, so delete that, and now actually this, let's say squared. x times y squared plus pi times y over z. Okay, so it's a three-dimensional matrix, complicated, hard to read. But if you format this in Wolfram language, you get much better. Shift enter. You see? Clarity. Okay, so let's copy this. Okay, let's copy this screenshot so that is this interesting, guys? Is this interesting? Okay, am I losing watchers? Okay, so anyway, that's a demonstration of table. Okay, so let's see. Okay, so let's put it back in our example here. So let's today's talk show. Wolfram language, paste it, syntax collect, show in browser. So today's talk show. Here is the code we did. Okay. Am I still going? Is it good? Everyone say hi. Check audio, check video, check. Okay. So let's continue. Let's see, where are we? So table, okay. Table, yeah. So here generating nested list with table. Okay, so that's an example here. Okay, so we want to, delete this part. So actually, we have already demonstrated this part. That's a multi-dimensional example. So let's go to the page and okay, so we want to, so nested, so delete. Generate a nested list. Okay, remove this section, basically showing browser. Okay, there. Okay, we already demonstrated this. Okay, so fantastic. So let's delete that. Next, duplicate with plus. Okay, so I want to show a different example here. So let's go to search for pre. So copy that. Let's not use Z, okay? The Z, because the simpler example, the better, okay? Let's just say 3. So run it. We demonstrated this before. Okay, so now let's format it so it's easier to see. Okay, and then we want to say, in this example, we just say x plus y plus y then you just got numbers in each. Okay, that's better example. Syntax correct, go back here, refresh. Simple example, simpler the better. Okay, duplicate with plus. I wanted to show an example where the expression gets simplified so that the actual result can be easily seen as a two-dimensional matrix. That's what that is about. Okay, so delete this screenshot. Now what is this? Generate a flat list h2. Okay, so in this table documentation tutorial I'm writing, what I want to do is I want to separate into different sections. Okay, because generate a flat list. Okay, yeah, I want to separate into sections. So the first part is generate a flat list, then the second part is generate rectangular array. Okay, so yeah, okay, so go to the top, table, cut, new section, the power of Emacs. Okay, and this section, move that to here. Okay, so move actually here, and here give it a new name. Okay, generate flat flat list. Okay, fantastic. Table, what it does, then example generating flat list, then generate rectangular array. Okay, so that's what this is about. Delete. Example, move up. So okay, are you guys bored with this? I'm alive. That's good. So if you have any questions, just ask me. Okay, there's not many people watching now, so you know, if you have questions related to what I'm talking about, so this is about example of symbolic expressions. So that is a flat list example. So that should move up to above. Okay. Yeah. So cut, one single key press, and make a section, paste it there, delete the time and to do, and cut the entire section, and go to the beginning of that tag, then say nested inside this section, and make it example symbolic expression. Okay, so this make this to h3 showing browser. So you got table, generate flat list section, subsection nested inside, example symbolic expression. Any part can be symbolic. That's right. Okay, and then and go down. Yeah, so you're gonna remove that HR. Okay, now this generate 3D matrix, do I need it? No, that's a screenshot from Wolfram notebook. I think let's just remove it. Okay, so search for the image file name to make sure it doesn't appear anywhere else. No. Okay, so open it, delete the image, and delete that. Okay, delete that, and back here, refresh. Arbitrary expression. Okay, so yeah, so let's modify that and move it to the flat example. Okay, so run it. Let's say divided by z. Wait, what? Divide by z times pi times I pi divided by z. Okay, run it. Actually divided by, let's say, x here. Okay, let's say that. Run it. Okay, let's just leave it like that. Divided by 3. Wait, where did the x? Yeah, x becomes 1, 2, 3. Yeah, so this is an example example of arbitrary expression. Okay, so put it back. Now cut. Okay, wait. Delete the section, then cut, then go to example above. Then paste it there. Then cut that. Then paste it that. Syntax color the whole page, show it. Fantastic. Now it's much more clear than before. You see, that's my working on my tutorial. So this delete, double check one more time. Yeah. Any questions? So next, text is okay. So this we already did. Delete. Okay, arbitrary expression, move up, delete. Now, okay, so now let's talk about another page. Close, back here, close, show in browser. Go to list operations. Now, before we were creating using table that generates a flat list or a rectangular array nested, okay? But now there's another function that's dedicated to just flat list. That's this one, range, okay? Stop the YouTube video, stop there. Okay, so let's paste, linkify, listify, merge the list, open it, and today's date, update it, okay? And then pre. So here is the code. Let's so this actually, yeah, so what we want to do is we actually want to make this okay, we want to make it separate boxes, okay? Min to max, paste it there. Okay, then here's an example with steps. Steps 0 to 5, symbolic step, next step, negative step, and we want to show one more example where the last item is dropped. So that would be, for example, actually here. So this, for example, if you say 0.7, so that's not evenly divisible, then the result will not reach 3. Okay, so if step is not evenly divisible by max, the result does not contain max. Now, did I spell divisible correct? So check. What? Correct. Okay. So now Okay. Syntax collateral showing browser. Fantastic. Okay, that's that. Okay, that's a formatting issue. Removing the blank line there. Delete. Okay, so now it gets more complex. Now this is about part. Okay, I think most people are bored. You kind of know what is this about. And I have to do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pages, 12, 13, 14. I got quite a few to do on these list operations with Wolfram language. But I think that's it for today. Thank you guys for watching. We talked about that's 1 hour. Okay. Bye, guys. Now, if you guys like my stuff, remember to go to xali.info, HTTP, no S, okay? Then go up, then programming language tutorials, then go up, hacker code, go up, XA code, xali.info, my homepage, then go to the bottom, you Patreon me, you Amazon gift card me, and you PayPal me. Thank you. Okay, that's it. Bye, guys. We shut down in 1 minute. So we were working on this page. Okay, close. So here is XA Talk Show today. After a while, you'll see my website updated. So